Can the internet really travel across oceans? People think that data is in the cloud, but it's not. It's in the ocean. Google's strategic negotiator for global infrastructure, Jayne Stowell, says, today, 10 trillion financial transactions are transmitted through internet optic cables submerged thousands of depths under the ocean across different continents. The internet is a pool of information that travels across the globe with the help of subsea cables. These wires can be as small as a strand of hair or as big as a garden hose when closed with thixotropic jelly and other insulation protective gear. Every day, you turn on your device and explore the digital world, surfing through millions of digital content and information for hours. But do you know how internet access travels to reach your device? Can the internet really travel across oceans? How does it work? How are internet cables laid? Why should you care? Who owns these cables? This video will offer in-depth coverage of these topics. The internet presently serves 4.57 billion users, around 59% of the world's population. So there's every likelihood that any problem that occurs with undersea cables will directly impact our lives and businesses. This is why we'll be talking about how submarine internet cables are repaired later in this video. Kindly stay tuned till the end because you don't want to miss it. According to Submarine Cable Map, over 400 internet fibre cable wires are currently sleeping on the ocean floor. A recent estimate by a telecommunications research company, Telegraphy, believes that the existing cables across the world cover a distance of around 1.5 million kilometres, powering 95% of our data, voice and other communication traffic. Some cables are quite small and only cover short distances, like the £12.5 million Celtic Connect cable stretching 131 kilometres from England to the Republic of Ireland. In contrast, others could be as long as the CME-3, which covers 39,000 kilometres to connect 33 countries across 4 continents, including Africa, Asia, Australia and Europe. But despite the incredibly long distance these undersea cables cover, they barely suffer a latency rate beyond 30 milliseconds. For instance, Maria, a subaquatic internet wire jointly owned by Microsoft and Facebook, transmits data 4,100 miles across the Atlantic at 160 terabits per second, making it one of the fastest submerged internet cables in the world. Time to get into the nitty-gritty. What are internet cables? Internet cables are fibre optic cables that transport data across the world. Can they really travel across oceans? Yes. Internet cables are laid on the seabed, moving millions of voices and internet traffic from one land-based cable station to another. Come to think of it, hanging long-distance internet cables such as Maria or the CME-3 on poles across continents would be an eyesore. It's a relief to have the option of laying them on the ocean floor. How do they work? Thanks to the ever-advancing world of technology, most of the new inventions we see around us are wireless. However, the backbones of these innovations, the internet, is powered by a network of wires submerged thousands of feet below the ocean. The moment you request information on your computer, your router moves the request as packets of data through the cables or cell tower provided by your internet service provider and delivers it to a data centre where the request is processed. A feedback or answer is then generated and sent back to your computer. But let's say you're requesting information hosted on a server overseas. In this case, your query travels several thousands of kilometres through undersea internet cables to reach the said server. Then the request is processed and a response is generated and sent back to your computer through the same route that transported them to the server in the first place. Sounds like a long process, yeah? Well, all of these things happen within a few seconds or milliseconds after you hit the send button on your device. On average, a single Google query will return an answer in 0.2 seconds. How are subaquatic internet cables laid? Special cable-laying sea vessels are specifically built to execute this year-long multi-million-dollar task. First, a sonar-equipped ship is sent out to scout the route where the cables will be laid. This is done to avoid areas that are prone to massive undersea currents, volcanic eruptions, mudslides, or territories that are heavily toiled by fishermen. Areas with mines and unexploded bombs are also avoided. After this is done, the cables are then loaded onto a special cable-laying vessel. This process can sometimes take up to 1 month. Then the ship sets sail, using its sizable underwater plough to dig a trench across the seabed where the cables will be laid. For wires that travel long distances, engineers install repeaters every 100 kilometres to amplify the signal. The cables are held aloft by buoys, an anchored float serving as a navigation mark before divers guide it to the seabed. When the cable arrives at the other end of the ocean, engineers pass it through a ready-made tunnel where it is connected to a terrestrial cable that leads to a cable station. Right before we jump into the last section, if you've made it this far, make sure to like and subscribe for more content like this. Why should you care? Contrary to widespread belief, the internet is everyone's business. As the world goes mobile, most companies and brands are moving online. Almost all modern equipment used across different industries is powered by the internet. Whatever your line of business is, there's a good chance you'll need the internet, meaning any disruptions to the subsea internet cables that connect your region to overseas cable stations will affect your business negatively. Who owns these cables? Laying fibre optics internet cables is not a menial task. It requires a range of sophisticated equipment, trained specialists, and a bottomless wallet. An average sea internet cable costs between $300 to $400 million. Most of the current undersea cables are a result of collaborative efforts from different giant tech companies and countries. For instance, Apricot, a 12,000 kilometre subsea internet cable that connects Singapore, Japan, Guam, the Philippines, Taiwan and Indonesia, is owned by a consortium of 5 companies. These companies include Google, Facebook, PLDT, Telco in the Philippines, NTT Limited and Changhua Telecom. The Maria internet cable, weighing £10.2 million, is funded by Google and Facebook, while a consortium of 52 companies owns the SeaMeWe3. Meanwhile, Facebook is extending its To Africa submerged internet cable by 8,000 kilometres. When completed, To Africa will become the world's longest undersea internet cable, travelling 45,000 kilometres between Europe, Africa, India, Pakistan and the Arabian Gulf. The social media giant says the project will provide internet access to 3 billion people across 33 countries. How are internet cables repaired? Engineers have to put on their wetsuits to travel to the bottom of the ocean to carry out repair and maintenance works on cables. In rare cases like Hurricane Sandy in 2012, natural disasters sometimes disrupt or destroy undersea internet cables. However, when a line is destroyed, it's mostly down to human errors in the process of using bottom-trawling fishing boats and nets and dropping ship anchors in the wrong location. When this happens, the cable operator or operators, as the case may be, would have to locate the damaged section. Then, a special cable ship escorted by a group of underwater cable repairers is sent out to correct the issue. The repair is done with the help of an underwater stainless steel chamber equipped with standard cable repair amenities needed by the team of repairers to undertake the task. The next step is to lower the chamber into the ocean and cover the damaged part of the cable. Water is then evacuated from the room, allowing engineers to gain access into the space through the small doors of the chamber that's only big enough to accommodate their hands and conduct repairs. For undersea cables located less than 6,500 feet underneath the water's surface, repairs and maintenance work can be done by transporting the damaged line into a ship and correcting the defect on board before lowering the cable back to the seabed. In situations where a shore end cable is damaged, the line is rolled out from the ocean onto the shore and floated by buoys and rope attached to a small crane on the coast, allowing the team to perform repairs. When this is done, the cable is then returned to its natural habitat. For now, fibre optic cables remain the most efficient way of sending data across the world. Currently, they transport over 95% of the world's data. Do you think these would change with the emergence of satellite internet transmission projects like Starlink? Be sure to check out our next video, One Day in the Life of Sundar Pichai, Google's CEO, who plays a massive role in the internet cable infrastructure.